Good morning, friends. Myself, Dr. M. Chennaya, and in today's video, we are going to learn the section of a square prism. Friend, a square prism, as the name indicates, will have a square bottom face, a square top face, and these two faces are connected by four rectangular lateral surfaces. And here, friends, the question for today's session reads like this. A square prism of side 30 mm and axis 70 mm long, resting on one of the end faces with a side of that normal to VP. So we have this square prism, and this square prism is resting on HP. My palm is the HP. Said that one of the base edges is normal to VP. So we'll place a prism on HP so that one of the base edges, say AB, is perpendicular to VP, and obtain the top view a square of 30 mm, front view a rectangle having side is equal to 30 and height is equal to 70, the height of the solid. So friends, I mark the top view a square of 30 millimeters side, and after marking that square of 30 mm, we will mark the name of the corners, like this is A, can mark, this is B, this is C, and this is D. A, B, C, D. By joining these diagonals, we obtain O, the center of this square. Friends, this is a top you have got. Let's obtain by projecting these edges and the axis the front view of the solid. So we will call this as O dash. O dash is the center of the top face. Join that to A dash, B dash, and C dash, D dash. This line on XY represents the square face in the front view. We will join this by straight line, that is O to A, O to B, O to C, O to D. Sorry, I made a small mistake. So this is a prism, and hence we have to mark a rectangle, not triangle. So friends, we will have a rectangle in the front view, and this rectangle will have a height is equal to 70 mm. That is given in the question. And let's mark this as A1 dash, B1 dash, C1 dash, D1 dash. Similarly, for the top face, it is A dash, B dash, C dash, D dash. Center is O dash. Center of the bottom face is O1 dash, and this vertical line is the axis O dash, O1 dash, which is normal to HP. This is how we obtain the front view and top view of the solid. So while marking this, you have to mark AA1, BB1, CC1, DD1. These are all the edges or the longer edges of the solid: AA1, BB1, CC1, DD1. So there are four longer edges which are seen as points in the top view. Friends, we have the front view, you have the top view, and let's see how the section plane cuts the solid. Here, he has specified that the section plane is normal to VP, so normal to VP, and is inclined to HP. He has not given where exactly it is cutting the solid, but he says that the true shape of the is a rectangle. So we have to cut this solid in such a way, this has to be cut in such a way that you should get a rectangle in the true shape. True shape is a rectangle. So friends, to get the true shape, The section plane has to cut all the four vertical edges because a rectangle has got four uh, corners. Now friends, it may cut like this at an angle to HP, or it may cut parallel to HP or parallel to the base. If it is cutting parallel to the base, you get the true shape which is seen as a square in the top view. So it has to cut necessarily all the four edges of the prism, but it should be inclined. At what angle? You know, when in one of the previous videos, we have shown that whatever the length you get here will be the longer edge of that rectangle. So short edge is going to be the side of the base or the bottom face. Friends, here what we can do, the section plane has to cut all the four longer edges. So what we can do, we can have some point here, some point anywhere on this, and taking the longer edge of that rectangle, which is 50 mm, I can strike an arc here. So friends, I've selected some point here at random and drawn an arc taking 50 millimeter radius. Remember friends, if you just join these two, fine. This is our section plane SS. To get more details about this, you can go through another video in the same chapter. Friends, this is our section plane and this will have a measurement of 50 millimeter. And even if you take it passing through the center also, not a problem. Only thing is this has to be 50. The longer it has to be 50. Friends, now we have the front view, and when we section and throw away the upper piece, means portion above that, the portion that is retained or left over is to be shown by dark visible line. This is the portion that is left over. We can call that part as P. The P is the portion that is left over after the upper part of the solid cut part is removed. Friends, here this will give you the front view of the solid. I will just mark it as FV. And friends, this is the top view as of now. But it says draw the sectional top view. That is, when you see this object which is cut like this is cut like this. When you look from the top, you are going to get the cut solid of the portion in the top view. So whenever a section plane is there above XY, is the section you are going to get in the top view. So friends, I am going to join or add this section, add this portion that is a square by drawing lines at an angle of 45 degrees to the horizontal, and I am going to darken the border. So this is the portion or the sectional top view of the solid. So written the sectional top view. I'll call this as STV, the sectional top view of the solid, that is the prism. So let us name this point, the corner. This point I can call it as 1, this as 2, this is 3, and this corner is 4. So corresponding to this, the points you get here are 1 comma 2 here, 3 and 4 are this point, 3 comma 4. So you got all the 4 points in the front view and also in the top view. We have completed the front view, we have completed the sectional top view, and true shape of the section is to be worked. And now I is also asking you, determine theta, the angle made by the section plane with HP. So before we go to the true shape, friends, you have got this You can write a line through this axis anywhere where it is cutting and measure this angle. This angle will give you theta, the inclination. I will say measure it. Measure theta using a protractor. You can measure it. This will give you the inclination of that section plane or the cutting plane with HP. That is asked in the question. Find theta, determine theta. So friends, we are finally left over with drawing the true shape of section, and we know very well that the true shape is a rectangle. So it has got a dimension 30 by 50. So to get the true shape of section, the procedure is we have to write lines perpendicular to SS at these points. So I am going to write a vertical from here or a line normal to this 3 and 4. So a line from here, another line from here. So we have got totally two lines passing through the point where the section plane is cutting them. So we'll draw another line parallel to this anywhere outside that figure, the front view. So friends, on this I should get the true shape. Let's see how to get the true shape on this. Friends, here the point 1 is at this distance from the xy. Mark this here. So I will call this as point number 1. Point number 2 is here. So from the xy, how far is that? So that is point 2, say. So friends, very obviously, this 1 to 2 is going to be 30 because that dimension is perpendicular to VP. Friends, similarly, we can obtain 3 and 4. So exactly opposite to this is 3 and the point 4 because 4 is nearer to xy. So nearer to this reference line. And whatever the points you have got here, join them by straight lines. This is point 4. So I am going to get a rectangle here. Rectangle. So I am going to join 1 to 2, 2 to 3, 3 to 4 and hatch this portion by lines inclined at an angle of 45 degrees to the horizontal. Friends, this is the true shape of this section. This is a rectangle as specified in the question, and this will have a dimension 30 by 50. So you can conclude that when the true shape is given to you, you will be able to locate the position of the section plane, and when the section plane is given, you will be able to obtain the true shape of the section. That's all in these videos. And friends, if you are happy with the presentation on this section of solid, do subscribe to my channel and share the information with all your friends. Have a wonderful day.